Mars has always fascinated us, especially with the question, could life exist on the red planet? For years, scientists have been exploring Mars with one central goal in mind, to find evidence of life, whether from the past or the present. While the surface of Mars today appears barren and hostile, new research suggests that life might still be hiding beneath the planet's surface, protected by layers of dusty ice. The idea centers around photosynthesis, a process that we know well from Earth. It's how plants, algae, and certain bacteria convert sunlight into energy, producing oxygen. But on Mars, harsh conditions make this process nearly impossible on the surface. The planet lacks a protective atmosphere, leaving it exposed to deadly radiation. This is where the ice comes in. Researchers believe that beneath layers of dusty Martian ice, the right conditions could exist for photosynthesis to take place, shielded from harmful radiation while still allowing enough sunlight to pass through. This discovery opens up a whole new possibility for where we should be looking for life on Mars. Instead of focusing on the planet's surface, it might be the dusty ice in the mid-latitudes of Mars that holds the key. This is where the delicate balance of sunlight and protection could create what scientists call radiative habitable zones. It's an exciting step forward, though it's important to remember that this is only a theory for now. No one is claiming that life has been found on Mars, but we now have a better idea of where to search. If you're as fascinated by the possibilities of life beyond Earth as we are, make sure to subscribe and like this video to stay updated on the latest space discoveries. While the idea of life on Mars is captivating, the reality of the planet's surface presents some major challenges. Mars is constantly bombarded by high levels of ultraviolet radiation due to its thin atmosphere and lack of a magnetic field. Without the protection we have on Earth, where our atmosphere and magnetic field act as shields, the Martian surface is a harsh, inhospitable place for any known form of life. This intense radiation breaks down complex molecules and would likely destroy any potential life forms exposed to it. However, this is where the role of Martian ice becomes even more intriguing. The dusty layers of ice, particularly in the mid-latitudes, could act as a natural shield, blocking harmful radiation and creating a more stable environment underneath. What's even more fascinating is that this ice isn't just a static barrier, it may also have the potential to trap sunlight in just the right way, creating the conditions necessary for photosynthesis to occur. Imagine layers of dust mixed with ice, allowing enough sunlight to seep through while protecting from the lethal radiation above. This balance could result in small pockets of liquid water underneath, a vital ingredient for life. Recent computer simulations have supported this theory, showing that with a thin enough layer of dust within the ice, the conditions could be just right to support microbial life. While this doesn't mean life exists there now, it certainly gives researchers a clear target. These icy, dusty zones in the mid-latitudes could be the most promising locations to search for signs of life on Mars. And as we explore further, these regions might reveal more clues about the planet's history, and whether life ever had a chance to thrive there. Stay tuned, because what comes next could completely redefine our understanding of life in the universe. Building on the idea of icy shelters beneath the Martian surface, we now turn to the scientific tools used to explore these possibilities. In the quest to understand whether Mars could support life, researchers have relied heavily on computer simulations to map out how the planet's ice behaves. These models simulate how dust and ice interact on Mars, particularly how dust, even in tiny amounts, can cause ice to melt beneath the surface. The findings are groundbreaking. It appears that under the right conditions, Mars' dusty ice can retain enough heat from the sun to create small, hidden pockets of liquid water. The importance of this discovery can't be overstated. Liquid water is a fundamental requirement for life as we know it. While Mars is incredibly dry now, with only frozen water found in its poles and underground, the presence of liquid water, however temporary or shallow, could mean the existence of environments where life might still persist or might have existed in the past. What makes this idea even more compelling is that it parallels phenomena observed here on Earth. In places like Antarctica and Greenland, we've discovered cryoconite holes, small, sun-warmed pockets of water that form under layers of ice and dust. In these pockets, microbes have been found living and thriving in harsh conditions, similar to what we believe might occur on Mars. These microorganisms can survive in dormant states through extreme cold and lack of sunlight, only reawakening when conditions allow. The potential for similar environments on Mars excites scientists, as it suggests that life, if it ever existed there, might still be hiding beneath layers of ice, waiting for the right conditions to awaken. Of course, all of this hinges on the dust-ice ratio being just right. Too much dust in the ice, and it would block too much sunlight, making photosynthesis impossible. Too little dust, and there wouldn't be enough heat trapped to maintain liquid water. But according to the simulations, even a dust content as low as 0.01% could create habitable conditions. The sweet spot seems to be where ice contains between 0.01% and 0.1% dust, a balance that could create radiative habitable zones at depths of just a few inches to several feet. This ongoing research is giving scientists their best clues yet about where to focus future Mars missions. Instead of the dry, barren surface we see today, the mid-latitude regions with their exposed dusty ice may hold the best chance of revealing whether Mars has ever supported life, or could still support it today. And while these findings are exciting, they're also just the beginning. With every new discovery, we inch closer to answering one of humanity's oldest questions: are we alone in the universe? What lies beneath Mars' ice could provide answers that transform our understanding of life in the cosmos. As we dig deeper into the possibility of life on Mars, it becomes clear that the discoveries we've made so far only scratch the surface, literally and figuratively. Much of Mars' potential for habitability lies beneath its surface, especially in its geological history. Billions of years ago, Mars was a very different planet. Thanks to the rover's curiosity and perseverance, as well as satellite observations, we've learned that ancient Mars had abundant liquid water. River valleys, deltas, and lake beds point to a time when water flowed freely across the planet, creating environments that, at least on Earth, would be ideal for life. These findings have led scientists to wonder, if Mars was once capable of supporting life, what happened to that potential? One of the leading theories is that Mars lost its atmosphere over time. Unlike Earth, which has a strong magnetic field that protects our planet from solar radiation, Mars' magnetic field weakened and eventually disappeared. Without this protective shield, the solar wind, a stream of charged particles from the Sun, stripped away much of Mars' atmosphere. This left the planet vulnerable, not just to solar radiation but also to the loss of water, as the thinning atmosphere couldn't prevent evaporation. Slowly, Mars transitioned from a wetter, potentially life-sustaining world to the cold, dry desert we see today. This disappearance of surface water is one of the biggest challenges to finding life on Mars now. Without liquid water, life as we know it cannot exist. And Mars' surface, blasted by intense UV radiation and subject to extreme temperature swings, seems unlikely to harbor anything alive today. But below the surface, it's a different story. While the planet's liquid water disappeared billions of years ago, we now know that ice still exists across much of Mars, sometimes buried just a few feet underground. The key question is whether any of that ice could melt into liquid water under the right conditions, and the answer, as we've discussed, appears to be yes, in specific places. But how do we actually find these hidden reservoirs of potential life? This is where the latest technologies come into play. Satellites like NASA's Mars Reconnaissance Orbiter, MRO, have been critical in mapping the planet's surface and discovering water ice in unexpected regions. However, detecting liquid water under the surface is much more challenging. That's why future missions, particularly those focused on drilling beneath Mars' surface, are so exciting. If we can penetrate these icy layers and sample the material underneath, we might be able to detect signs of past or even present life. Finding life on Mars would be a monumental discovery, but it wouldn't come without challenges. The conditions beneath the surface, where photosynthesis might occur in pockets of liquid water, would likely support only microbial life, if anything at all. These microorganisms, if they exist, would be unlike anything we've seen on Earth. On our planet, even in the harshest environments, life finds a way to adapt. Extremophiles, microorganisms that thrive in extreme conditions such as high radiation, intense pressure, and extreme temperatures, offer a glimpse of what Martian life might look like. In places like deep-sea hydrothermal vents or the frozen deserts of Antarctica, life endures against all odds. Could the same be true beneath the ice on Mars? This possibility has scientists considering not just where life might exist on Mars, but how to detect it. One promising avenue is the study of biosignatures, the chemical or physical indicators of life. These could be certain gases, like methane or oxygen, produced by biological processes. Mars has already intrigued scientists with its methane spikes, sudden increases in the amount of methane detected in its atmosphere, which could potentially be linked to microbial life. While there are other explanations for these methane fluctuations, the presence of even a small amount of methane keeps the door open to the idea that life, however basic, could still persist on Mars. Another intriguing clue comes from the study of ancient Martian rocks. Certain minerals found by the Perseverance rover have been formed in the presence of water, and some of these minerals are associated with microbial life on Earth. By analyzing the chemical makeup of Martian rocks and soils, scientists hope to find traces of organic molecules, carbon-based compounds that are the building blocks of life. Even if we don't find living organisms, discovering remnants of ancient microbial life would be an astonishing revelation, showing that life once thrived on a planet other than Earth. The search for life on Mars is also forcing us to rethink what we define as life. On Earth, life is fundamentally linked to water, carbon, and oxygen. But could there be entirely different life forms, based on different chemistry, hidden away in the Martian ice? While the answer is purely speculative at this point, it's a question worth asking as we expand our search for life beyond the traditional models we know from Earth. As we continue to explore Mars, one thing becomes clear: even if we don't find life as we know it, the search itself is invaluable. It teaches us more about our own planet's history, the conditions that support life, and what it takes for life to endure in the harshest environments. It also helps to refine our techniques, tools, and questions as we prepare to explore other worlds, such as the icy moons of Jupiter and Saturn, where conditions similar to Mars' mid-latitudes might exist on an even larger scale. For now, though, Mars remains our best bet for finding life close to home. Each new discovery brings us one step closer to answering the age-old question: are we truly alone in the universe? The next frontier in this search may well be buried beneath a thin layer of Martian ice. And as technology advances, so too does our hope that Mars may eventually reveal its secrets. What will those secrets tell us about our place in the cosmos? The answers could change everything. As we look to the future, the search for life on Mars is far from over. With new missions and advanced technology, we are closer than ever to uncovering whether the red planet once harbored life, or perhaps still does beneath its icy surface. The discovery of even the smallest microbial life would reshape our understanding of the universe and our place in it. If you're as eager as we are to explore these mysteries, subscribe and join us as we journey beyond Earth, chasing the answers that lie hidden in the stars.